lengthy assignment today. You're going to get a full work day tomorrow. Wait to give me the evil look till after you've heard me say the whole piece. All right, yep. All right, so what do you think U is going to be for number 6? So du dx. Don't forget the dx. Oh no! The dx means it's a differential. It comes from somewhere. It comes from something. This means that you can take the derivative of, or that this comes from a derivative. That once we find the answer, say the answer is x to the fifth, which it's not, but then when we take the derivative of that, we would come up with this. It is a derivative of something. Within your substitution, there are times, I'll admit, where I've done some tricky substitution techniques, and it would be helpful for me if it would be very helpful if I didn't have a dx. But you have to have it. You can't just play games and say, oh, I'm going to pretend like it's not there. I'll be very, very... So, you got to have it in there. So, I've got that. What do I do to create the 4x plus 2? Oh, wait. So 2 du is equal to 4x plus 2 dx. That takes care of that top part. And the bottom will be u to the third. So I'll write the integral 2 du. What goes on? U to the negative 3. What's the antiderivative of u to the negative third? Right? What happens to the 2's? You get negative 1 over u squared. X squared plus x minus 1 u squared plus the constant. Seven. Integral e to the x over e to the x plus 1. You might be tempted to say that u would be e to the x. But if you do that, what? You could try that. All that will change is that you have e to the u over e to the u plus 1. And it's really the same problem. So, very good. So if you had u is equal to e to the x, then du would be e to the x. And that doesn't take care of this 1. So if you say that u is e to the x plus 1, then du is e to the x dx. So that's the right choice. You might ask, how do you know? You don't. It's like asking you if, you could factor something. And sometimes you don't always know. You got to be really good at it. You got to practice. So now that you've seen this example, I can replace the e to the x dx with simply du. And now I write 1 over u. And I'll see who's which one. E to the x dx is du. So I have a 1 over, and then e to the x plus 1 is u. If you took u to the negative 1 and you added 1, you get u to the 0 divided by 0. And that's not an option. It doesn't work, does it? You know the answer. You've done very well with this. Natural log, thank you. Remember that the derivative of natural log is 1 over x. So the antiderivative of 1 over u is natural log of u plus a constant. So natural log of e to the x plus 1 plus a constant. the derivative of e to the x is e to the x. The derivative of the constant 1 is 0. Now, Hannah, you brought up a good question. What if we forget to write the dx? And I will tell you that, say you don't write it there, but you do the rest of the problem correctly, I will not mark it wrong on your test. But I will say that when I got to college, that's what I told you about. One of my tests, I got 100% on, except he gave me 98 out of 100. And I couldn't find where I made a mistake. He said, well, you didn't write dx then. I said, well, I got the right antiderivative. He said, yeah, you still got room for it. Okay. So it didn't matter. He was just trying to make a point that your notation should be correct. I won't do that to you. I just want you to know that rings kind of true to me. Almost had that. Didn't matter, right? He was just reading. All right. What's that? It matters. No. It doesn't make me a better teacher or worse teacher. Just gives me stories. Okay, this one. Oh no! Should u be sine of x or cosine of x? Because the derivative of sine is cosine, the derivative of cosine is negative sine. Which one do I choose? Why? Okay, Haley has said two things here. One is wrong, one is right. So let's try to decipher. The two things she's said that I would like to focus on, one is wrong and one is right, is that u should be cosine of x. The other thing she said is that it is on the inside. Which is the correct statement? Do we choose cosine of x or do we choose what's on the inside? What's on the inside? Cosine's not on the inside. Sine is on the inside. Why is sine on the inside? Because sine is being squared, right? I mean, this isn't much different, folks, than 4 times, say, 4 plus x squared, quantity squared, times, say, 2x. So you can see that this thing is being squared just like here, and that the derivative of the inside is 2x. That's what's sitting here, right? It's really not that much different. So, therefore, if I choose u is equal to the sine of x, that's what I'm taking to a power. That's what would require the use of the chain rule when I took the derivative. I have du is equal to positive cosine of x dx. Remember, we're taking the derivative, not the antiderivative. Yes, multiply by 4. Exactly. Same place that all the other ones went. Where did the cube go? It's right here in the problem. We will use it, just not right now. Well, I have a 4 cosine. I mean, I can move things around. Multiplication is commutative. U is sine of x. So I have the integral of, instead of sine squared, I write u squared. And instead of 4 cosine of x dx, I write 4 du. So I have the 4, the cosine, the dx are the same as 4 du. So those three can be replaced by those two. Antiderivative of u squared. U cubed over 3 plus c times 4. So 4 times sine cubed of x over 3 plus a constant. Flip it over. Try 4 more. Here we go. Evaluate the following indefinite integral. What is different about this one? Both quantities have an exponent. Good. What else? When you take the derivative of the inside, what do you get? 2x. I'm not worried about the 2. But I just come up with x. Boy, it sure would be nice to come up with an x cubed. The problems we've done so far are really kind of easy and middle level problems. These are a little bit harder. You say cube it. Good idea, but it doesn't work out. I'll show you why. So we're going to try something else. We're going to say what you would obviously say, which is u is equal to x squared plus 2. So du is 2x dx. First, I'm going to divide by the 2. 1 half du is equal to x dx. Now, here's the problem, okay? What you'd like to suggest is that we would have two options. Number one, if we cube both sides, then we would get an x cubed, but you'd also get a dx cubed. That's not something we can really do, okay? That doesn't make sense in terms of calculus. The other thing you might say is, well, let's multiply through by an x to create an x cubed. But then you get u times x, and we want just u. We don't want an x. So what I'm going to do is I'm going to rewrite this, and then we're going to see if you can see the aha moment. I'm going to write it as this x squared times x times x squared plus 2 to the 5th dx. Can you see that those two expressions are in fact the same? So what I did is I just pulled the x cubed apart to be an x squared and an x. You can see that x dx is taken up by 1 half du, isn't it? Furthermore, the x squared plus 2 is taken up by u. So I have all the pieces accounted for. I don't need to worry about the 5th power. That will be used in my antiderivative. What I do have to worry about is the leftover x squared. Great idea. A lot of people do it. At the end of the day, I have to end up with u because I'm making a substitution of the variable u. No x's can be left over. I need to somehow come up with an expression for x squared that involves u. U minus 2 is equal to x squared. So that becomes my substitution for x squared. For x squared. One of the x's from the x cubed gets taken up by the 1 half du. I can't have another variable other than u. I can have a minus 2. This is still an expression in terms of u. I couldn't have an x in it. So as I make my substitution, watch what I have. Instead of x squared, what do I write? U minus 2. Put in parentheses. Instead of x dx, what do I write? Instead of x dx, 1 half du. Instead of x squared plus 2 to the 5th, u to the 5th. Now, we can do this. It's not a big deal. But some people will try to simply take the antiderivative of u minus 2 and then the antiderivative of u to the 5th. That's not a good idea. That's like doing the reverse product rule, and you don't know how to do that yet. You have to write this as a power. So it's 1 half times the integral of u to the 6th minus 2u to the 5th du. Now that it's written as a power or polynomial, I can go ahead and take the antiderivative using our basic rule for the antiderivative. So it'll be u to the 7th over 7 all multiplied by 1/2 minus 2u to the 6th over 6 plus a constant. Now as I distribute my 1/2, I'll simplify my fractions. I get u to the 7th, and u is x squared plus 2. Whoop. Don't do that. X squared plus 2 to the 7th over 14 minus the 2's cancel, so I get x squared plus 2 to the 6th over 6 plus a constant. A little trickier, huh? The next one follows nearly identical to the one we just did. I'm going to ask that you try the next one on your own. Okay. I'll just do the u is equal to x to the third minus 4. U is equal to 3x squared dx. I don't want the 3, but I do want a 4. So 4 over 3 du is equal to 4x squared dx. You can see here that I have a 4x squared and I have a dx. What I need is an x to the third. Well, x to the third is equal to what? U plus 4. So this piece is going to go in right there. This piece, this u is going to go in right there. So I end up with 4/3 times the integral of, instead of 4x squared dx, we have 4/3 du. Instead of an x to the third, I have u plus 4. And instead of an x to the third minus 4, I have a u, and it's to the third power. Okay? Distribute your u to the third, 4 over 3 times the integral of u to the fourth plus 4u to the third du. What is the antiderivative of u to the fourth? U to the fifth over 5 plus antiderivative of 4u to the third. 4u to the fourth over 4, which would be u to the fourth. Multiply by your 4/3, and you get what it is. X to the third minus 4 to the fifth power times 4 over 15 plus x to the third minus 4 to the fourth plus a constant. Times 4 over 3. There you have it. We'll try one that's easier. We'll try one that's harder. Okay. What do you think? Why? Good. Now, please be very careful with this type of problem, because here's your options. If you choose u to be cotangent, the derivative of cotangent is negative cosecant squared. So you come up with most of that, don't you? But that won't work. You choose u to be cosecant of x, because it's on the inside, it's being taken to the fourth power. And so du is equal to the derivative of cosecant. Wow. Thank you for being honest. Why? So I don't have a negative up here. So I'm going to separate this because I have a cosecant and a cotangent here, but here I've got 4 of them. So I'm going to raise the integral of cosecant cubed of x times cosecant of x times cotangent of x dx. See what I did? I pulled one of the cosecants off. No. Because that matches negative du. Right? Cosecant to the third times cosecant gives you cosecant to the fourth. I've just kind of factored it a little bit. So we got this negative integral of well, instead of cosecant to the third, what do I write? U to the third. Because this is your du. So negative du takes up one of those cosecants. That's why you can't do u to the fourth. Yep. So the antiderivative u to the third is u to the fourth over 4. And it's negative plus a constant. Substitute u back in. You got negative cosecant the fourth of x over 4 plus constant. Bada bing, bada bam, bada booski. Nope. Haley, if you were to rank your enthusiasm on a scale of 1 to 10 for integrals by substitution, 4. 7. All right. A solid 5. Okay. I'm sitting at 9.8. The problems are a little too easy still. We need something a little bit more challenging. Give me something I don't know. Yep. Last example for the day, and tomorrow you'll do 2 checkpoints. But you will not have an assignment. You will just work on the stuff that we have. But we got to do a couple checkpoints, see if you know what the heck is going on. Because I'm worried. I'm worried. Hi there. Thank you. All right. Anybody, u is equal to 3 minus x. Du is equal to negative 1 dx. I want a 3. So I'm going to multiply by negative 3 du is equal to 3 dx. So I've got that. That is negative 3 du. That is u. So you're looking at the fact I got an x squared left over. Okay, so she sees it. I'm going to express it just a little bit differently, okay? Here's what Hannah says. The x squared is x times x, correct? So I could solve for x. X would be 3 minus u. I could just write that twice up there. I'm going to choose to write it like this. I'm going to add the x and subtract the u. So x equals 3 minus u. Then I'm simply going to square both sides, which is the same as what you stated, right? You take it and multiply by itself. So I get x squared is equal to 9 what? My 6u plus u squared. So now I have a substitution for x squared as well. This 9 minus 6u plus u squared goes right into the x squared piece. Well, that's just like all the other problems. You know, the fourth power here kind of just came along for the ride. That's what we were using to take the antiderivative. So it was the general form for the antiderivative. So here we go. The integral of negative 3 du, and then, so that 3 is gone. The dx is gone. Instead of the x squared, what do I put on top? U squared minus 6u plus 9. All over u to the 1/4. Thank you, Cole. She should say it louder then. Yeah! Yeah, bring it! All right, yeah. Say it like it matters. Well, no, I'm just saying sometimes when people give answers in class, like, and then somebody else will say it, but like, hey, nice job. I said it. Well, speak up. Say it with authority. Like Herbie. I mean, when Herbie says the answer, it's like the voice of God spoke. You know what I mean? It's like, you know, it's just there, right? All right. All right. All right. Here we go. So, I got to divide. I'm going to rewrite this 2 as 8/4. Rewrite the 1 as 4/4. And this is x to the 0, so 0/4. So it'll be negative 3 times the integral of what? No, we got to rewrite it. We don't know what we're doing yet for an antiderivative. U to the 7/4. Thank you. Minus 6u to the 3/4. Way to be on a roll. Take it, Allison. Because I'm rewriting the 2 as 8/4 so I can subtract it. Because well, should be u to the 0. My bad. But so the idea is this is being divided by u to the 1/4. I've got to, as I'm dividing these pieces, I have to subtract the exponents. So I've got 8/4 minus 1/4. I got 4/4 minus 1/4, and I got 0/4 minus 1/4 is negative 1/4. All right. Almost there. Because right now it's 9u to the 0/4. Because anything to 0 is because x to the 5th divided by x to the 5th is, which is x to the 0. Okay, so negative 3 times, what's the antiderivative of u to the 7/4? U to the 11/4 divided by 11/4 or multiplied by 4/11 minus 6u to the 7/4 divided by 7/4 multiplied by 4/7 plus 9u to the 3/4 divided by 3/4 or multiplied by 4/3 plus a constant. Now all I gotta do is multiply through by my negative 3 and plug in my u value. And it looks like u is 3 minus x. So I have negative 12 times 3 minus x to the 11/4 power over 11. Plus, let's see, 4 times 6 is 24, times 3 is 72. 72, 3 minus x to the 7th over 4 over 7. Be a minus. The 3's will cancel, so I get 36 times 3 minus x to the 3 over 4 plus a constant. And you may say to yourself, big deal. Well, look at what you just did. Yep. You found out that the antiderivative of that is that, honestly, other than by using the substitution principles that we had, how on earth would you do that type of problem? I mean, you'd have to guess a lot. There you got it. Yo. Area beneath curve, right? So that's number one. Second of all, we talked about accumulation functions. So like, you're given a rate, like rate at which snow is falling. The antiderivative will then tell you the entire accumulation. So there's all sorts of things in the real world that we need accumulation functions for. And that's the antiderivative piece. All right. Here's your assignment. It looks lengthy, but you guys, it's just two sections. It's 5-4 and 5-5. That's all we're covering before the test. And in previous years, if I haven't given enough homework problems, people do poorly on the test. So for any teachers out there listening, no, I do not subscribe to the idea that 2 practice problems is enough to be sufficient, even though that's the way some modern educators think of things. I was just told that by the other day by an education expert.